Okay, so in this question, what you've been asked to do is you've been asked to, a rocket is fired vertically upwards. So after t seconds, so t is time and it's in seconds, its height, which is h in meters, is given by the formula h is equal to 100t minus 5 times t to be squared. So this function here gives you the height at a particular time. So question 1 then, what it asks you to do is, it asks you to get the height of the rocket after 2 seconds. So if this here, so all we have to do is, we take this function here and we let t equal 2 seconds. So we substitute the value into this function. So let's work on that one. So question 1 then, so part 1. So the height is equal to 100t minus 5 times t to be squared. And what we're saying is that we're letting t be equal to 2 seconds. So t is equal to 2 seconds. And we want to find out, well, what's the height after 2 seconds, the height of the rocket? So we just substitute in our value for t. So it's going to be 100 times 2 minus 5 times 2 to be squared. So this is, so 2 by 100 is 200 minus, so 2 to be squared is 4. 4 by minus 5 is minus 20. So therefore 200 minus 20 is equal to 180. So it's going to be 180 meters. So what we can say is that after 2 seconds, using this function here that tells us the relationship between the height of the rocket and the time taken, the height of the rocket is going to be at, it's going to be at 180 meters. So the second one then is the speed of the rocket after 3 seconds. So if this guy here gives us, for example, the change in distance in relation to the change in time, then the second derivative of this is going to give us the speed. So we have to differentiate this. So question 2, part 2. So if h is equal to 100t minus 5t squared, so it tells us the relationship of the distance in relation to time. The speed then is going to be equal to dh dt. So that's the relationship between this in relation to time. So we just get the second function. So this, so we differentiate this. So t, so that just becomes 100 minus, so 2, so we take the power multiplied by the coefficient and then drop the power by 1. So that just becomes minus 10 minus 10t. Okay, so that's our, so in order to get speed, speed is going to be equal to 100 minus t times minus 10 times t. And it asks us for what is the speed of the rocket after 3 seconds. So when t is equal to 3, what's the speed? So we have to take this value here and substitute it into this expression. So that's going to become, so therefore the speed is going to be equal to 100 minus 10 times 3. So remember, 3 I'm getting here from the question. So we work this out. So that's going to be equal to, so it's 100 minus 30. And then we have to, so 100 minus 30, that's going to be equal to 70. And remember, we're talking about speed. So it's going to be the unit of the change in height, which is in meters. So it's going to be 70 meters per second, which is the unit for time. So after 3 seconds, the rocket's speed will be 70 meters per second. So that's that second one. So question 3 then is, after how many seconds the rocket is momentarily at rest. So what we're saying is that, like, what's the time for example, what's the time on this guy? So remember, this is the speed or the rate of change or the slope. So what we're trying to find out is what's the value for t when this is equal to 0, when the speed is 0. So when the rocket is momentarily at rest. So for part 3 then, so we take this expression, this guy here, and we let it equal to 0. So we're going to have 100 minus 10 times t is equal to 0. So remember, we're looking at, the question asks us for after how many seconds the rocket is momentarily at rest. So when the rocket's momentarily at rest, its speed will be 0. So this here is the expression that tells us the function that we can use to work out speed. And what we do is, the question asks us what's the time when the speed is 0. So we take this expression and we let it equal 0, and then we solve for t. So what we have to do here is we want to get t on its own. So this is plus 100. So in order to get rid of the 100 on this side, I have to minus 100. If I minus 100 on this side, I have to minus 100 on this side. So these guys will cancel out. Plus 100 minus 100 will cancel out. And it's going to be minus 10 times t is equal to minus 100. So now I want to get rid of this minus 10 from in front of the t. So I have to, this is minus 10 multiplied by t. So the opposite of multiplication is division. So I have to divide this side. Divide this side by minus 10. And if I divide this side by minus 10, I have to divide this side by minus 10. So divide this by minus 10. So that will enable me, these two will cancel out. And t then is going to be equal to minus 100 minus 10 divided by minus 10, which will just be equal to 10. Remember, when you're dividing integers and the signs are the same, the answer will have it'll be a positive integer, which in this case is 10. So going back to the question then, so the question asks us, so after how many seconds the rocket is momentarily at rest? And what we can say is that using this, after 10 seconds, this is your answer here. So after 10 seconds, the rocket is momentarily at rest. The speed for the rocket is 0, and we figured out that the time that happens is 10 seconds. So the last part of the question then is, so the maximum height reached by the rocket. So what's the maximum height it has reached? So we can see that after 10 seconds it reaches its maximum height. So you can imagine, so this is the rocket, it goes up a maximum height, stops here, and then it starts to come back down again. So this point here is the maximum height. So what we can say is that, so imagine, so the x-axis, x is equal to time. So we can see here that the maximum is at 10 seconds. So what we want to find out is at 10 seconds, what's the height? So what's this height here? That's the unknown. So what we have to do is we have a formula to work out height. So we have this guy here. So this is in the question. So remember, we have it here. So we can tell the height at a given time. All we do is substitute the value into this function. So we take our function and we substitute in the value for 10, and 10 is like when it's at the maximum height. So that's when the slope is 0. So the speed is 0, and therefore the height, we want to find out what's the height, what's the corresponding y value. So question 4 then. So we take our, so height is equal to 100t minus 5 times t to be squared. And we want to find out what's this value for h, what's the height after 10 seconds. So t is equal to 10. So we substitute the value in here. So it's going to be 100 times 10 minus 5 times 10 to be squared, like so. So we just multiply this out. So 100 multiplied by 10 is 1000. Minus, so 10 by 10 is 100. And minus 5 by 100 is minus 500. So then we have 1000 minus 500. That's equal to 500. And the unit for height, it's in meters. So it's going to be meters. So what we can say then, just going back to our question here. So the question then is, what's the maximum height reached by the rocket? Well, the maximum height when it gets up here to its maximum height, its height is 500 meters. And that's your answer here. And that's how you work that one out. So 500 meters. So hopefully that makes sense. And that's just an example of a rate of change question using calculus. So thank you for listening.